Hi, this is Victor Gamov with Confluent. Kafka Streams is a Java library that allows you to write stream processing applications. Spring Boot and Spring Kafka include support for Kafka Streams, so you can include these capabilities and write your event-driven microservices using Spring Boot and Kafka Streams. So let's take a look how we can do this. For the purpose of today's exercise, we're going to be using this classic example of all possible data processing frameworks. We're going to be using word count. Since we already have some information from book, in this particular case, we have information from our Hobbit book. We're going to process this and get the count of words, how many words and how often they occur in this quote. So let's get to it. For the sake of this exercise, I'm not gonna start writing these Kafka streams from scratch, even though it's pretty simple to do. I will use a quick start that's available on the Confluent website that already have everything that I need. So if you want to learn a little bit more about Kafka streams, go to our YouTube channel or on developer.confluent.io. You can find materials about Kafka streams. In this case, I want to show you some of the integration bits that are available for you in Spring Boot and Spring Kafka. Let's create another class called processor. In our processor class, we will have a method called public void process. In order to use or create a topology in our application, we need to use streams builder. That's class that will be used to instantiate Kafka Streams instance. And Spring Boot already have a support to this, so it can inject Streams builder in our code, so we don't need to do this manually. So let's do this one. Called builder. And that's going to be implementation. Now, in order to do so, we need to say it's going to be auto-wired. Also, I need to say this is a component. And also, I need to tell this Spring Boot application that enable Kafka streams. In this case, it will start looking for certain configurations we're going to be talking about in a few seconds. In our Streams Builder, we're going to be using all these kind of things here. This is where we initialize our serializers. That's what we do. Next thing is that we need to specify where we need to read this data. So since we already have this data in our Hobbit topic, we're going to be using this one. So next thing is that in this particular case, we don't specify. So we're going to be doing the split. We're going to be splitting all these sentences, all these quotes into words. And after that, we group by key. And this particular key would be word. I know for a fact that we need to also specify serializer and deserializer here for grouping. So in this case, we will be group as a string Saturday, and as a value we're going to be using string. So we're going to be using string as our key. We're going to be grouping by key, so in this case we're going to need to specify those Saturday. And another thing that we're consuming this message not from the string, we're consuming this message from Saturday's dot integer. I'll create the variable integer Saturday, and we're consuming this as an integer Saturday over here and integer over here. So we fixed our types. Our builder was injected here. We're creating a stream here. And next thing is that we do have this streams word count topic. Now on the previous lessons we learned how we can create a new topic. So in this case we're gonna say new topic counts, return topic builder name, and with number of partitions it's gonna be 6, and replication factor is 3, and we run the build method and we make it as a bin. So in our application configuration, we also need to specify a couple things. So Kafka streams replication factor for all internal topics that Kafka Streams will create for repartitioning, for state store. All these topics also need to have a replication factor. We need to set this here in the configuration because it will not allow me to create the topics with default replication factor, which is 1. That's what I need to do. It's a Confluent Cloud specific, or if you have a cluster that runs on certain defaults. Confluent Cloud always enforces some of the good defaults that you as a user needs to be aware, and basically don't need to think about this. And also I need to do Kafka Streams application ID. I will call it Spring Boot Streams. So in this case, it will be using this as our application ID. It's also a mandatory field that we need to create for our application. And once again, let's see what we're doing here. So we do have, we're reading these messages from our Hobbit. We are doing some parsing in our application side of things. And after that, we do grouping, we do count, and after that, we're writing the result back to topic. So in this case, we will be able to see some of the data. All right. I'll go ahead and run this application. I will be looking for running state. So it's going into states. The topic was not created, so it created this topic. Now, application should be up and running, and we should be able to see application state translation from rebalancing to running. So application is up and running. Now when I switch from my application code into my Confluent Cloud UI, I should be able to see all these topics that were created, and there's a topic called word count output that we created programmatically. We also can see that some of the data is actually arriving to this topic. So let's take a look. What do we have here? In messages UI, we will be able to see the counts. In this case, we're going to be using key as our string, as our word, and our count would be our value. That's we supposedly should be able to see in a few seconds. So let's take a look in a different view. So what we see here, our key is actually our word, and our value is something that JavaScript UI will not be able to read. Why is that? Because we're using long serializer, which is Java specific, so it puts some bytes that's not standard. Since we're using string, and the Java usually produce UTF-8 Unicode string, so it will be able to consume this string anywhere. So in this case, including the JavaScript. So we see something is going on here. But the way how we can read this data, we can modify our consumer and read this data from the console. So let's get to it. Let's stop my application. Go to my consumer code. I will change the name of the topic to streams word count. This is going to be what we're going to be consuming here. And consumer record in this case is going to be string and long. Also, we need to modify consumer code. So in this case, it will be using as a key string deserializer, and it will be using as a value long deserializer. And now I should be able to see all these messages in my console. So once again, my producer will create the codes for the Hobbit. My Kafka Streams application will try to do word count, and my consumer now will be writing this down in our console. So let's get to it and let's see how it works. We should be able to see those messages in a few seconds. So this is our key. Let's see if we can see some plugins. Dragon. All right, so some dragons here, and we know getting the count of this. Now, all this is very interesting and it's very cool, but really place where the Kafka Streams and Spring Boot really shine together when we need to build a REST endpoint to access this state store for this application. So in this case, instead of reading through all this topic and reading all these messages here, we will try to get access to those on demand. So that's the next thing that we're going to be doing here. So let's create another class. We're going to call it REST controller that will expose some of the information about the state store from within Kafka Streams application to REST API. REST service. And it's going to be a REST controller. We're going to be using this streams builder factory bean that allows us to get access to Kafka Streams instance. And Kafka Streams instance allows us to get access to a state store. So that's going to be what we're going to be using here. And it's going to be private, final. We're going to be using required argument constructor as well to generate this. So that we'll be using this. And the next thing is the public, say, we need to get a count, so it's going to be long and get count. We're going to be using string as our word that we need to get access, word, and that's going to be our code, return something. Now, it's going to be get mapping. We're going to be using this, say, slash count slash a word, and in this case we're going to be using this path variable as a word. Now from the factory bean we can get a Kafka Streams instance. So Kafka Streams instance, this is all your like Kafka Streams API. That's your instance of Kafka Streams. So from this I can do store store query parameter for named and type. So we need to have a store name. We'll get back to it. Counts. Next thing is that style is the key value store. What's the queryable store types dot, and it's key value store. Now we're getting this store where our counts and will be string, and it's gonna be long. And when I do counts dot get by key, I'll put the word, and this is what I will be returning to my application. Now, so we have this REST endpoint, but we don't have the store name. So in order to do so, we need to get back to our word counts and materialize as counts. So in this case, it will create the local state store with the name counts that will be available for querying. If you want to learn more about how does it work, we have materials in our developer.confluent.io website where you can learn all about Kafka Streams and how the state store works. Also, you can check out this Confluent YouTube channel with the live streams playlist where you can find all things around materialized view. I was talking about this in a lot in details in the past. So let's see how this will work. So now I will restart my application. So now what I can do here, I can do HTTP to my 8080. And in this case, I'm gonna do, what was the endpoint? Count Hobbit. So 3 times Hobbit was appearing here. So maybe something like, I don't know, like dragon. 11 times dragon. So in this case, my application, my Kafka Streams Spring Boot applications, not only a processing application, but also as API server. In this case, my instance of my application also exposes some of the internal information to outside world. Now, let's recap what we learned today. So you can use Kafka Streams applications inside the Spring Boot. You need to just enable integration by enabling this annotation. You will be able to just inject the Streams builder, and the Kafka Streams instance will be managed by Spring. Also, from this bin, Stream Builder Factory bin, you will be able to get access to an instance of this application in case you need to get access to state stores like this one. I'm getting the state store for name counts, and for the type is a key value store that allows you to expose this store to outside world and make it your application as API server. And once again, so let's take a look what we have here. So we have a topic with this data that's generated. We do have a streams count, and the data is processing here. Let's use this very nice data lineage thing. So we will see that there's some bunch of applications producing this data into my topic. With Hobbit, we have a KeyStreams application that processes this data and writes data inside inside this streams count topic. This topic also consumed by Spring Boot Kafka application, which is my consumer now. And there's a bunch of other things that we're using some of the topics to state to save the state for this application. All right, so now you have it. Now you know how we can use Kafka Streams together with Spring Boot and Spring Kafka. You can use powerful stateful stream processing library that allows us not only to do processing but also expose state and intermediate computation through the REST API that's available in the Spring Boot. Stick around for new learnings, and don't forget to check out developer.confluent.io and the Confluent YouTube channel.